Now this illustration deals with motor loads in accordance with NEC 220.50 and NEC 430.24. Now in the illustration we have four motors: a 10 horsepower motor, a 20 horsepower motor, a 25 horsepower motor, and a 30 horsepower motor. These motors are three-phase 460 volt Design B, and as stated before, the Design B represents the procedure and manner in which the manufacturer manufactures the motor. Now, reviewing the boxed-in information, we have calculating the load for motors. 430.6A1 refers to table 430.250 for three-phase motors, and to use the 460 volt column. Now the 460 volt column is used for 440 volt motors, 460 volt motors, and for 480 volt motors. A 440 volt motor is usually a U-frame motor. A 460 volt motor is usually a T-frame. And a 480 volt motor is usually a special wound motor in some manner. Now the 10 horsepower motor using our 460 volt column is 14 amps. The 20 horsepower motor is 27. The 25 horsepower motor is 34. And the 30 horsepower motor is 40 amps. Now in step 2, we would take these full load current ratings of the motor, and we would take them all at 100%. So when we add the 40, 34, 27, and 14 amps, we come up with 115 amps total load. To convert the amps into VA, we go to step 3, and we would take 115 amps times 480 times the square root of 3, which is 1.732, and we use 831 volt. And when we do our math, we come up with a VA rating of 95,565. Now, the solution for this particular calculation, the motor load is 95,565 VA. But now let's make a note. However, if one of the motors is the largest motor, and you're adding all the loads together that we've been looking at so far, then the largest motor or compressor loads that we've looked at previously would be used as the largest motor, and we take it at 25%. But if the test, for example, asks for a feeder circuit or service entrance conductor, then we would take the 40 amp motor at 125%, add it to 34, 27, and 14, and we would derive a total of 125 amp. And we would use this rating to size the conductors for a feeder for such a circuit as you see outlined here. So keep that in mind. And then that load 7, where we would take 25% of the largest motor if we're adding all loads together to obtain the VA rating for a feeder or for service entrance conductors, which we will look at a form that will list all these loads so we get a feel for what's taking place here. But keep in mind, I have been told that most of your test problems will be figuring an individual load as you see here. So you'd be taking the step 2 and taking the 40 amps at 125%, adding the other motors at 100% to come up with a total of 125 amps to size the conductors for a feeder circuit. And that's what this illustration 2-14 is illustrating.